So I want the inside to have a 7. I'm not sure this is going to show up as purple. We'll see. So let me rewrite this and give myself a little room to play with. I didn't give myself any room. I gave myself a little room. It's okay, Jeff. I want a 7 in here, yes? So at the same time, I better put an over 7 outside. What did I just do to the integral? I multiply by 7 and divide by 7. So what did I actually just do? I multiplied the integral by 1. And what happens when I multiply by 1? Stays the same. Nothing I do can make the integral become something different, or else I'm going to get a different answer than I should. Yes? Okay, some of you guys are looking, you want to hurt me. Okay. So, if I want to do this, let's say 3/16. How do I do 1/2 minus 3/16? What do I do?
Find a common denominator.
Common denominator. Yes. And what would that be?
It would be 8 over 16.
It'd be 16. So I'm going to multiply by 8, and I'm also going to divide by 8. Yes? Did I actually just change the value of the number? 1/2 was 0.5, 8/16 is 0.5. So as long as I do two opposite operations, I didn't change the original problem. Okay. Blah, 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 who cares? So over here, what else? So if I put a times 7 inside, if I put a divided by 7 outside, I didn't do shit. It's the same exact integral it was before. What else do I need to show up inside? So du shows up. Du hasn't shown up yet. It's almost here. I need an over 5. So I need to divide the inside by 5. So I better do what at the same time? Multiply the outside by 5. So you can see reciprocals happen in there. Yes? So the shortcut is, if the inside needs a 2/3, I put a 3/2 on the outside. Because when I multiply reciprocals, I get 1, and I can multiply anything in the universe by 1. Okay, are you guys with me? Okay. Now listen. Things get trippy when you start mixing basic shit with advanced shit. I understand this. But do you see how this old idea of like denominators, for example, we're using the same idea we had back then. I can multiply by 1 anytime I want to. Now can I find du? Can you find this? 7/5 x to the 2/5 dx. Is it in there? Is it in there? Like ragu. That's old reference. Here's 7/5 x to the 2/5 dx. What is all that shit then? That is du. That is du by definition. Du based on the choice we made. And then what do I have left? So all of this is du. I have a 5/7 integral, and then what's this? Sine of what do we call this?
U.
Me. Sine of u. I love the grammar. When we start doing u stuff, grammar goes out the door. What is u? So, are y'all a little better with this idea? If I pick u and I take a derivative and there's a number there that I don't have, I can make it show up easy. And just to point this out again, what does this integral say? Sine of stuff times the derivative of stuff. Sine of stuff times the derivative of stuff. They're the same stupid integral. Just like the u cubed minus plus v cubed, that was like the w to the fifth blah, blah, blah. Too many details. That is all we need. All I need to know is the structure, not the details. I can bring the details back later. I just need to know the structure. What's the integral of sine? Almost. Negative cosine. Okay, so this would be negative 5/7 cosine u plus c, yes? And then what's the last thing I got to do?
Reintroduce the value.
Bring x back, yeah. So just replace U with this business. Pussy, plop. How are we doing so far? Is this coming back, or I don't know? I think most of you guys have taken 180 relatively recently. I don't think I've had anybody that hasn't had 180 since 10 years ago or something. 10 years ago, most of you guys were like 9. So I doubt you were taking Calc 1 then. Maybe you were, I don't know. Look at number 3. I always like giving number 3 immediately. Because this is the whole idea about why I say 90% of the time this, but 100% of the time this. If you had to, don't just ignore if you happen to know how to do number 3. Just tell me this. What looks to be stuck in number 3? What looks like it's stuck somewhere?
X in the denominator.
X is stuck in the denominator. But if I let u equal x, I don't get natural log of x for the derivative, do I? So what works 100% of the time? Is there a function in there whose derivative is also in there? What's the derivative of natural log of x? And there's a 1 over x in there. All right. That is u sub period. The idea of looking for the inside function, we teach it that way because it makes 97% of problems easier. But what should you always look for? Is there a function in there whose derivative is also in there? If you see that, u sub works. So if I let u equal natural log of x, go ahead and try to do this problem. Let u equal natural log of x. I'll give you that piece. Try to do that, number 3. Yeah. Yeah. Because if you put 7 this here, and there's a dx, this is dx, or yeah, du, sorry. Yes? But what allowed you to put that 7 this here? I should use 7 this. What allowed you to put that there? So you multiplied the interval by 7 this. At the same time, you should multiply by 5 sevenths. So if you need a 7 this to show up inside, you have to put a 5 sevenths on the outside. Because, well, okay. Because that's what you use.
Yeah.
So this is the thing. So right.
In the original interval, do you have a 7 this x to the 2 fifths?
And you're going to make your substitution. So
we
like
need
you
a
said,
7 fifths to show up.
U becomes up.
I need a 7 fifths in front of this in order for me to find
I'm going du is equal to what?
Okay, good. So if I put a 7 fifths there, I've changed the problem. But if at the same time I multiply by 5 sevenths, what did I actually just do? Multiply by 1. And I'm allowed to do that all day. And I mean, that's the fundamental reason why like denominators work. Since I'm doing it to the top and the bottom, they cancel. Integration. If I do it to the inside and then do the opposite on the outside, I didn't do anything. I always explain it first fully, and then I did
So
just say that.
how would
Say,
you make this up?
If you need a 2/3 inside, you put the correct outside.
How would you do
Then you can. I need you to understand why that works, and then you can compress it. Then you can shortcut it.
So let's take the easy part. So the easy part is ln is equal to okay. So that's you.
So if you're at home, I didn't start recording until later. So let me flash some of the earlier work to you guys. Oh my God, this is a mess.
What do you got?
Here, this is a good one. This is the second problem on the worksheet. let u equal this
So, okay.
business.
I see your concept.
We need a
So
7/5.
maybe write the integral.
So therefore, I must at the same time do this. So overall, I did nothing.
Times 1 over.
If I replace all the x stuff with the u stuff, I get a much easier integral.
Because this
Okay.
is that, right?
Mm-hmm.
And what's that?
I was talking to the future people that
Yeah,
might
so
watch
it's
this
on the
video.
bottom or it's on the top? Yeah, it's on the top.
So this is, I'm pretty sure I've done this one.
Yeah.
Almost all.
Does that make sense?
Yeah. I'm pretty sure that's how I trying to make sure.
Yeah, there you go.
I really-
The only thing,
What's that?
I mean, the only thing is,
So you got to answer.
you would divide by 2.
Do you know that
Yes.
integral of u?
You can't, if you multiply both sides by 2, you get 4x plus 12. But you don't even have to do all that shit. You just have to put a 1/2 outside, and then you get a 2 inside.
Square.
I mean, either way actually ends up in the same place.
So do you square? Yeah, there you go.
This problem needs to be silly quick. The minute you let u equal ln x, what's du? 1 over x dx. I've got all that shit. I don't need to introduce anything. I don't have to like do reciprocals. All that shit's in there. So I'm going to put a u where ln is. So if I rewrite this, just to make this a little easier to look at. Here's an ln. Here's a 1 over x dx. This is u. This is du. And what's the integral of u du? Yeah. Plus c. And then I just replace u with what I said it was. Choo. Okay.
Can I have an x squared over 2?
Do it again? Oh yeah, you're good.
Let's see.
My fault. I don't know. I sometimes do it one way and the other way. That way, I just wanted to do it that way. So I'm not sure why. What's the main difference with number 4?
It's a definite integral.
It's a definite integral. I guess I do. That's all right. I guess I do sort of had time. Yeah. Since you two are doing like volumes of revolution right now, yes.
Knowing area between curves 6.1.
Okay. And us, we haven't. If you're with me, we haven't actually talked about Calc 2 yet. To be honest, we're gonna do that today. This is okay that I'm almost out of time because we can just focus on trig on Monday because that's going to be in everybody's near future or all the trig related stuff. So let's focus on number 4. I might talk a little bit about trig and then we'll call it a day here in a bit. Let's look at number 4. Does anyone have a suggestion? Let me write it again. On what to do here? And Chuck might remember how ugly this could get if U sub doesn't work. You might have to use sub. This one is really nice, thank God. So what's the only thing that makes sense to let U equal here?
Denominator.
Why? 2 reasons.
One because well, I mean, based off doing it for a while, it's gonna be 1 over u, which.
Oh, okay.
Yeah.
The bottom has a higher degree than the top.
Right.
So if I let U equal the bottom, its derivative has a good chance to be the top. You guys see that? So if I see an x to the 5th somewhere and an x to the 4th, I want to let U equal x to the 5th. Its derivative has a chance to match what I need outside. You guys see that? And then, of course, the other thing is x squared plus 6x is the part that's stuck. But we saw in the previous problem, it doesn't have to be there to be what I let U equal. But in this case, I'm definitely going to let U equal x squared plus 6x. What's du?
2x plus 6. Oh, dx.
Cool. And then what? Let's see if this is okay. I almost have that, don't I? I almost have that on the top. Yes? Because the bottom is going to be U, because that's where we made the bottom U. I just need the top to be replaced. What does the top need? A factor of 2. So if I multiply the inside by 2, what do I do at the same time?
Divide by 2.
Divide the outside by 2. I did not change the integral at all. I just made it look different. I reorganized it so that the inside is doable now. So what is 2x plus 3 times dx? What is this? What is that equal to?
2u.
It's equal to du. Yes? That's 2x plus 6 dx, which is du. So this is all du. Then I'll have 1 over this we called u. And then what's the only other thing so are there any x's left? No, thank God. Yes? If there was an x left somewhere, I've screwed up. I can't go further. There isn't. We replace all the x shit with u shit. Except for one thing. Remind me what these numbers are all about.
Those are x values for element.
That is what x is doing. I need to know what u is doing. How do I figure that out? Do I have a relationship between x and u? Yeah, where's that?
At the very
Oh yeah, we made it. So when x is 1, what's u? When x is 1,
7.
7. When x is 3, what's u? 27. Yes? And now is that integral stupid easy? Yes. Right? What's the integral of 1 over u? Okay, what happened? Everybody's like, yes, it's stupid easy, and then we can't do a job. ln of u. Be a little more precise. In general, what is it? Be careful. There's one thing you left off.
Natural log of absolute value.
Yes. In this case, why do I not really need that?
It's a definite.
Because all my inputs are positive. So I don't really need that, but you need to stay in practice. Yes.
Why does it have to be absolute value?
Yes. See, that's what I make a big point is. That question right there kicks so much ass. Don't just accept that shit. Don't just sit there and go, I've never understood and just never will, so screw everything. No, say why the shit is it? No, you don't have to say why the shit is it. You could if you want to, that's not going to offend me. So I'll ask it that way. Why the shit is... By the way, you guys cool, you just plug 27 and 7 in? Yes, let's just finish this stupid thing out. So I get this, who cares? Yeah, blah, 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 whatever that number is, who cares? Yes? Is that cool? Okay. Why is this equal to... Where the shit did the absolute value come from? What the hell is going on, Jeff? What's wrong with you math people? Why can't you just make anything easy? Can somebody tell me what the domain of 1 over x is? What's the domain of 1 over x? Don't put it in arrow notation. You can just tell me. No. What's the only thing I can't put into 1 divided by x?
0.
I can put negative numbers in, can't I? What's 1 divided by negative 1? Okay, so it can handle negatives. It can handle positives. It can't handle 0. So if I thought erroneously that this was this, on the surface that is wrong. Because what's this domain of this? Now hit me, all positive numbers. And I think that's why you said that, because you saw it was even. So do those domains match? There you go. I have to make this the absolute value so the domains match. In fact, here's, what's natural log look like? Do you guys remember? Anybody? Can anybody draw a natural log in the air for me? Anybody? No? Yeah. It's just this, yes? Yes? Well, that's from my perspective. From your perspective, this, yes. You with me? What's happening here? There's a There's a There's a what here? There's an asymptote, yes? There's a black hole right here. You guys with me? And that's why the domain is all positive numbers. What is the natural log of the absolute value of x look like? It looks like this. Because now it can handle positive and negative inputs, yes? Okay, now watch this. what does 1 over x look like? It looks like this. What does the natural log of the absolute value of x look like? It looks like this. So the derivative of the natural log of the absolute value is equal to 1 over x. Does that make sense? What's the slope here? What's the slope here? Tell me anything about the slope. Anything. I'll take anything about the slope. It's negative. Here it is small negative. Here it's big negative, yes? Small negative, big negative, yes? Here this is small, this is big positive, small. Big positive, small. So that is the derivative, at least on a cursory graphical overlook, yes? So if I did not put the absolute value, a whole half of this shit would be missing. It could never match with this. The domains have to be equal in general. Does that make any more sense? Okay. You don't just have to say yes. It's like, just please stop talking to me. You know, if I explain it and it still doesn't make sense, that doesn't bother me. That's when I get excited, because that's when that's teaching. Teaching is explaining something and the guy goes, I don't have a clue what you said. And I'm like, oh sweet, I have to come up with an entirely different way to explain this. Is why I love my job. Okay. But that's the kind of question I need you to ask in this class. You don't have to hold back about anything. I want you to really pick up on this fact. And are any of you going to judge anybody else in this class? Let's just get this out. Does anybody have a reason to judge what anybody else says, unless you say something like, you know, just horrendous, like racism? Then I'm going to make some fun of it. But if we just say something wrong about math, everybody else in here is going to go, I can relate to that shit, right? I mean, you see what I'm saying? So there's no reason to hold back. Yes? My job is to rein you guys in. I need you to feel comfortable just saying what you're thinking right now. You could be really close. You could be wrong, but really close, and then we can talk about why you weren't quite all the way there. Okay. So, last thing for today. I want to say something real quick about trig stuff. I gave you guys the trig laws sheet last time, I believe, the green sheet. That's a really good little dude just to have kind of like hanging out with you.
Did we finish work?
Do it again.
Did we finish work?
Yeah, I thought we did. Didn't we plug in?
Quickly, yes.
Yeah, I just plugged it right here. I just plugged the 27 and the 7 in. That's why in this specific problem, we didn't need the absolute value, because we knew all of our inputs were positive. Yes? Yes.
I forgot. Where did you get 27 and 7 from?
Oh, 1 and 3 are what x is doing. When x is 1, u is 1 squared plus 6 times 1, 7.
Oh, so you just...
When x is 3, u is 27.
The new integral
Yeah.
we have made, we need
The
to
minute
solve
you
it with respect to.
the minute you define what u is, you've made a relationship between u and x.
Mm-hmm.
So now you can just take all the old x values and convert them into u values. And then you don't have to bring x back at the end. That's the great thing about definite integration. You change the limits, you can screw the original problem. Who cares? Okay. Oh my gosh. I believe last time I did talk about trig values, didn't I? I can't remember now, because it kind of overlaps with some tutoring I did. Did I talk about? All right, I want to leave this up to you. The last thing I want to do today, I'm going to give you two options. Does anyone want to go over why square root of 3 over 2 is a thing? Why is the square root of 3 over 2, Jeff? Why is the cosine of 30 degrees square root of 3 over 2? Why isn't it something else? Or do you want to start talking about trig identities and how they kind of like build each other? We're going to eventually do both of these things. Which one? Either one of those sound more interesting. Or two? Trig identities. Okay. So I think last time I did talk about the Pythagorean identities a bit. Yes? And then if you divide by, for example, if you just divide by cosine squared, what is sine over cosine? Tangent. So this is tangent squared. Something divided by itself is 1. 1 over cosine is secant. So there's another Pythagorean identity. If you divide by sine squared instead, you get 1 plus cotangent squared is cosecant squared. See the analogy. See that you don't have to memorize a whole bunch of shit, just like derivatives. You guys kind of with me? Okay. Where things get more interesting. Let me see. How much do I want to talk about that? Yeah, that's all right. I'll talk about this one. Do you guys remember what this is?
Isn't it sine A plus sine B, or?
It's definitely not a linear operator. It's not distributive. Sine is way too funky for that shit. Right? A square root can't even distribute. So sine definitely can't distribute. It's freakier than square roots.
This is the one you showed us with the.
This is the one that leads to cosine being an asshole. I did talk about that, didn't
I don't remember if it was in this class or if it was
Oh,
yesterday.
I? Maybe. Cosine is an asshole, just so you guys know. Sine of a plus b, sine takes turns and says, here, I'll play with a, you play with b. I'll keep this a plus, and then let's trade. I'll take b and you take a. Now, I could show you the derivation of this. That would take a long time, and I don't know if I want to do that, so that could be like office hours. If you want to know where that came from, I could show you the way that I derived it. Cosine is an asshole. He says, I play with both of them first. Screw you, sine. You got a plus, I'm going to make it a minus. I'm done. Here, you play with this shit. Okay. And again, that's not exactly technical explanation, but who cares? There's a whole derivation for why these are what they are, and then on top of that, I give a way to remember them. Sine takes turns, leaves it a plus. Cosine's an asshole. Him first, minus, now you play sine. Can you guys figure out what sine of 2 theta would be then? What is sine of 2 theta? Because I can't stress to you enough how, maybe you can back me up on this, I don't know how long it's been since you took Calc 2, but how important all your trig identities are immediately in this class. Chapter 7, you don't have to agree if you're like,
No, I
full
agree.
of shit.
Yeah, no, that's right.
Especially, we'll get to the half angle formulas, they come up a lot. But all of them come up to some degree. Can anyone see how to get, just from what I told you, how could you get what sine of 2 theta is? Just from what I wrote up there. You can do it.
You would multiply by 2.
No. What is 2 theta? Can somebody break that down for me? Don't use multiplication. What's 2 theta? You can do it. What's 2 theta? What's 2x? Don't explain it with multiplication. What is 2x? You can do it. What is 2x? Give me a problem whose answer is 2x. A very simple problem. You can do it. I'm in beginning algebra. Give me a problem whose answer is 2x. Very simple problem.
10x minus 8x.
I like it. Even more simple. X plus x. Good. So the 2 tells me how many of the thing I'm adding. So what is sine of 2 theta? What's another way to write that? Sine of theta plus theta. Do I have a rule for what to do when I have sine of 2 angles adding? Do I? So what would I do? A goes here, B goes there. Yes? What's going to go in both places now? Do it. Do it. Just put a theta everywhere. Do it. Put a theta everywhere. Just put it all over the place. How low can this go? Hello. Okay. Again, I can't stress this enough. I know some of you guys, I'm your teacher in Calc 2. In Calc 2, you got to do shit. You got to show me what you know. In this class, we can talk about whatever. You can get whatever wrong you need to. Get it out your system. Get all the wrong shit out. Now, because I'm not grading you. Get it out. Let it lay on the floor. Look at it. Stomp on it. Go, get out of here. All right. So how do I rewrite this then? It would be I put this one here, and I put that one there. So what do I get?
2 sine theta.
No, don't get to the end. Just tell me immediately what it is.
Sine theta.
Sine theta? Cosine theta?
Sine theta, cosine theta.
Sine theta, cosine theta. I appreciate your patience. You're like, I told you just to multiply by 2, but you didn't establish what you're multiplying by 2. Okay, so I got 2 of these, yes? Yes? That is the double angle formula for sine. Sine of double theta is 2 sine theta cosine theta. Does that sound familiar to anybody? Does that sound familiar to anybody? Okay, good. One of you guys is at least humor me with this stuff. Just go keep. Has it been a long time for us since trig? Is that what's happening? Or potentially some of you guys, has anybody never had trig? I mean, I've had students in my, oh yeah, we talk about it. Oh yeah, no, you've had trig.
Yeah.
Okay. If you somehow got to Calc 2 without trig, number 1, I'm sorry. You should not have been able to do that shit. Number 2, you got a lot over your head. Okay. Yeah, oh god, I gotta stop. So this is a big time identity. You'll find that on that green sheet. That will show up sometimes. This one leads to the double angle for cosine, which leads to the half angle formula, which is going to show up a lot. Alright. I think that's enough for today. That's plenty. I think we go to 1:50. Good. So some of you guys, I will see you tomorrow morning. Some of you guys, whenever. Yes?
I just had a question about number 3.
Yeah. Let me turn my camera off. Thanks, Chuck.